All right, guys, let's continue our discussion of validity threats. As we discuss validity threats, we are going to see that they fall into two different camps. The first is internal validity, and the second is external validity or generalizability. Validity threats, it's important to remember, are those considerations for the messiness of research with people and eliminating possible alternatives that could explain our findings. We want our independent variable to be what has caused the change in our dependent variable. Other things, such as those extraneous variables or sampling issues or errors, could lead our results to reflect something different, to where our findings are influenced not only by our independent variable, but by these other concepts as well. So validity, controlling for validity, is going to make sure that we control for those external pieces, to where what we find in our final conclusions is reflective of what happened with our independent variable, that it's not due to something else that's going on in that particular case. This is something that is of greater importance whenever we're doing social research or research on human subjects in general. Anytime that we're interacting with people, people are messy in a way that bacteria in a petri dish are not. Or not as complicated. So let's say I'm looking at, if I'm doing a study on a certain type of bacteria in a lab, I can control the temperature of the lab. I put them in the two little petri dishes. I control what nutrients go in to feed the bacteria. I control how much bacteria is there. I control how much light they get. I control everything. And so in one of those petri dishes, I give it maybe more sunlight than I give the other one for some reason. I can control and measure all of those variables. So the threats of extraneous variables interfering with what's going on there is pretty small. However, when I'm dealing with people, it's a little bit more complicated. So somebody could be in my weight loss study, but I don't have that same level of control of what they do when they go home. I can't control what they eat when they go home. I can't control if they're doing the exercises they're supposed to do. I can't control if they're documenting everything the way that they should. And I can encourage them to do it, but then there's also the element of maybe they think they're doing it right and they're not. Maybe their idea of what a portion of cheese looks like is different than what my idea is. So we're having all of this miscommunication, we're having all of these external factors. All of these things are having an impact on whether or not that person is successful at the end of this weight loss program that I'm studying. All of those extraneous factors are coming in to influence it. So I don't know to which degree those factors led to the change and what degree my independent variable, the thing that I'm testing in this particular example, a weight loss program, leads to that change. So when we're talking about threats to validity, we're not trying to control all of them. We want to control them as much as possible, but having a study that has no threat to validity is very unlikely. I'm not going to say impossible, but it is very unlikely. It's impossible in the sense that there's so many things that we can't control for. And while we strive to control for one, we end up limiting the ability of the other one. So to explain that a little further, I'm going to introduce the two topics of internal validity and external validity. Internal validity has to do with things that more or less happen within the study. So internal validity has to do with those changes observed in the dependent variable or due to changes in the independent variable. This is where I'm controlling for those extraneous variables that can happen or occur during the actual process of the study. An example of this would be maturation, for example. Maturation is one of the examples in the textbook. It is probably one of the more common ones whenever we're dealing with humans, and it has to do with physiological changes. So an example of maturation would be if an experimenter claimed that a series of prescribed play activities were effective in promoting bladder control in infants. As evidence, he presented information that only 2% of the 15-month-old infants starting his study had control, that's bladder control, and that at the end of the study 9 months later, 75% of the infants had achieved control. So according to his statistics, there is a significant difference between the bladder control from when they started until they ended. And let's say he controlled for all of these other extraneous variables in this particular study. So his conclusion would be this activity, this play activity that he's doing promotes bladder control and it was successful. An extraneous variable that we cannot control explicitly in terms of removing it from a study is this idea that a baby is going to naturally develop better bladder control from the time that they're 15 months old, so just over a year, till the time that they're 2 years old, whenever people often start potty training children. So we don't know what percentage of this improvement is due to his program, this play activity that he has set up for children. And we don't know what percentage is due to the fact that bladder control is something that children would just naturally develop. The same thing also applies to people on a day-to-day basis. So let's say I want to compare how well a new phonics, I know phonics is a bad word, what's a new word? A new literacy program, sorry. A new literacy program is working. I feel like somewhere Dr. Kirkland right now is just felt a shiver of fear whenever I said phonics, rightfully so. So my apologies to Dr. Kirkland. So a literacy program, if we developed a literacy program where we want to see if it improved literacy scores, and we give the test to our treatment group in the morning, so the group that got the literacy program, we give them their post-test in the morning and we collect their grades. And then our control group, we test them in the last hour of the day and then we collect their grades. And we find that the control group scored way lower than the treatment group at the beginning of the day. So looking at those two, we could say, well, they're at the same school, they have the same teachers. The only thing that's different between the two is the fact that one had this program and the other one didn't. And that's why they had this change. The program caused this change. That's not truly accurate because the other thing that changed was also how the children felt over the course of the day. Humans, on average, of course, there's some exceptions, but physiologically, mentally, we're more alert in the morning than we are in the evening after a long day. Those of you that take night classes here at UAB know that after you've worked 8 hours a day, you're far less able or far less motivated to participate in class in the evening, to be alert, to be on your best at your best level of participation versus if you would have taken that class at 10 a.m. in the morning and you had nothing else to do before that class. So physiologically, you're mentally tired, you're a little bit more worn down at the end of the day. So how much of that difference between the first hour class and the last hour class, how much of that first hour's success was due to the fact that they were in the morning, and how many of the points that last hour, the control group's class, that lost the points, how many of those points were due to the fact that they were just tired and that they would have gained those points if they would have taken it in the morning? So that's an example of maturation and how maturation will have an effect on a study. As you can see from those two examples, these are all things that happened within the study. These are things that happened before we publish it, before we write up our conclusions. There are things that could make our initial conclusions maybe not quite as strong or as sound as we think that they are. We have some other examples that I will put in a little game that we do later. But before we go into that, I want to talk a little bit about external validity. So in internal validity, we were specifically looking at how people interact with the study and things that are happening within the study, those things that we as the researchers can control for. Whenever we're looking at external validity, these are things that we can control for to a certain degree. However, they're going to influence our study in a different way. So external validity has to do with maybe you controlled everything within your study, that your treatment group and your control group were truly equal. In the example of maturation that I gave earlier, where the afternoon group was more tired than the earlier group, those control groups and treatment groups weren't truly equal because one was taking their test much later. And so they had some factors working against them that the morning group did not. So whenever we're looking at external validity, this is more closely related to generalizability. How do we generalize it to the world outside of our testing environment? So I've done this great study, but perhaps in trying to control for everything in my study, I have set up my study in a way to where my findings don't really apply to other scenarios outside of the study. So a couple examples of that to kind of further that definition. One is the Hawthorne effect. If any of you were psychology majors at some point or took a few psychology courses, you're probably familiar with this one. A subject or participant's behavior may be influenced partly by his or her perception of the experiment and how he or she should respond to the external stimuli. So this comes from a factory study quite some time ago. And in the study, I believe they were looking to see how people would react or work at varying different levels of lighting within the building. And so one of the things that they did was they decided to use researchers who were observing people working, and they would change the level of lighting that people get over the course of the day within this particular place to see how it influenced the way that they were working. I don't remember what the conclusions were, and the conclusions aren't really important. At that particular point, they had, the control group and the treatment group all kind of had the same effect of everything. So the internal validity was pretty sound. The problem that they had, though, was that whenever they tried to transfer these findings into other places, let's say started applying these ideas of like, yes, we found people work better with, when the lights were on really strong versus whenever the lights were kind of dim or whatever their findings were, they found that those findings weren't being replicated in other places. They didn't have that reliability. They weren't able to see those things in other circumstances. So what they found in the Hawthorne effect was it was strictly the idea that people knew they were being watched in that study. So the treatment group and the control group both knew they were being watched. So it's kind of been controlled as something that's differential between the two. However, whenever they tried to share those findings elsewhere, when factories were implementing this in their own factories, they found that they weren't getting those same results that the researchers got. And that was because people weren't watching them all day. They were working harder with the lighting at a certain degree because people were watching them. It's the same thing whenever, for those of you, if you remember back to when you were in school, those of you who have worked as teachers, you're familiar with this. Students are always better behaved whenever the principal walks in than when the principal's not there. It has nothing to do with the teaching of the teacher or the lesson that's being taught. It's strictly the idea that they know that they're being seen. They're being watched. So they're changing their behavior because somebody there is watching them. So that would be an example of the Hawthorne effect, which would be external. Another one has to do with, what's a good example? Novelty and disruption effects is one that we can kind of relate to. The experimental results, whether they're positive or negative, may be due in part to the enthusiasm or disruption generated by the newness of the treatment. The effect of some new program in a setting where change is common may be very different from the effect in a setting where few changes have been experienced. So an example of this would be, let's say we are doing a study with computers, and we are putting we're doing a study of a new math program that students use on the computer. And you can substitute math for whatever subject is of interest to you. There is a new program that students or participants are doing on the computer. And they put it in a school, and they find that the students' math scores and interest in math go up significantly. And so they conclude that this worked, that this program worked really well for those students. When they try to generalize this and share this with other places, they find that the program didn't have as much effect in other places. So what could have caused that? In this particular example, they could have had a control and a treatment in this school. One class had it, one class didn't, a control and a treatment. But what it could be is perhaps that school never had any computers before. And so now there is a computer lab and the teacher's using a computer in class. So it's new and the students are engaged, not necessarily because of the computer itself, or because of the program itself, but just this new novelty or disrupted event that's taking place in this classroom. Now, if we try to take that same program and we try to use it in another school that maybe has had computers in the classroom and students are used to working on the computers all day, every day, they're not going to be as excited to get on the computer. So maybe we don't see that same jump in, interest of doing math in other schools as we see in this school. So for some of those, and relation to external validity, have to do with that sampling selection. Is our sample representative of our population? Are we only sampling schools who are maybe don't traditionally have a lot of funding and therefore don't have as much technology as other schools do? And maybe those findings aren't going to apply to schools that have technology all the time. Maybe we selected from a particular region and that region is not really reflective of education practice across the state or across the country. So all of these things have to do with sampling. If we didn't accurately capture our population, then our results won't be able to reflect the population. They would just be able to reflect the subsection of the population that we have sampled. I know these can be kind of confusing. What you will find in a lot of examples is that multiple threats will apply. So I am going to share with you guys a Jeopardy activity that we do when we teach this course on ground. I will record a video explaining how to use this particular thing. Obviously, you're not going to break into groups because you guys will be doing this independently, but it'll walk you through some more examples so that you can test your understanding. And as you start to see maybe some of those areas that you're struggling with a little bit, you can send it on over and I'm happy to discuss those with you. Mertens does a great job of breaking down each of these in there, and you will also have an activity in this module that will ask you to apply it to something in your area. So if you have any questions, let me know and I will see you online.